In this video, I will show the 6 testing machines every serious forging supplier must have. If they do not have them, walk away. My name is Rahul Agarwal, Director at Prestech Forgings and Engineering Private Limited. We help global sourcing managers eliminate risk by combining forging excellence with laboratory grade verification. Over the years, I have spoken to dozens of buyers across Europe and the US, and one thing is clear: many trust the production line but never ask about the lab. That's a mistake. The 6 machines every serious supplier should have. Number 1, spectrometer, chemical composition analyzer. Forging starts with steel, but not all steel is created equal. A spectrometer ensures the raw material you receive actually matches the actual required grade. It detects carbon, manganese, chromium, molybdenum, and other alloying elements within seconds using optical emission spectroscopy. This test is performed to evaluate incoming raw material inspection. Each heat is tested before forging begins. No blind acceptance based on mill certificates. Heat-wise batch segregation ensures parts are never mixed between different chemical grades. Audit trail links spectrometer readings to each heat number and production batch. If your supplier does not test what they buy, they are outsourcing quality to a piece of paper. Number 2, universal testing machine. Once the forging is done, the real test begins literally. The UTM applies controlled tension to test the mechanical properties of a forged sample. Tensile strength, yield strength, percentage elongation. This test is performed to evaluate batch-wise mechanical testing. Each heat-treated batch is sampled and broken under load to verify it meets the specification. Process validation confirms the forging plus heat treatment process has resulted in the desired mechanical performance. Customer documentation results are captured and logged, not recreated from old reports. Clients ask for tensile properties. Smart suppliers give them data, not recycled PDFs. Number 3, impact testing machine, Charpy or IZOT. A part may be strong, but is it tough? Impact testing measures how much energy a sample absorbs before fracturing, especially in low temperature or dynamic load conditions. The Charpy or IZOT method uses a swing pendulum to impact a notched specimen and measure energy observation. In this test is performed to evaluate low temperature application parts used in minings, railways or defense require impact toughness, not just static strength. Heat treatment validation ensures the quenching and tempering process did not leave the material brittle. Design feedback loop, weak toughness, recheck grain structure, alloy content or quenching process. Strength without ductility is a setup for sudden failure. Impact test reveals that risk. Number 4, hardness tester. The surface may look perfect, but is it hard enough to survive wear and load? Hardness testing quickly checks if the part surface matches the required hardness, usually measured in BHNL, Brinell hardness number, or HRC, Rockwell hardness C. This test is performed to evaluate the post heat treatment check, confirms quenching and tempering have performed the desired hardness range. Surface uniformity validation detects decarburization or soft spots from poor furnace control. Case depth confirmation in some parts confirms case hardening effectiveness for components requiring surface wear resistance. Visual checks cannot detect soft surfaces, only a hardness test can. Number 5, metallurgical microscope to check grain and structure analysis. The secret to High performance forging lies inside the material. A metallurgical microscope examines grain size, grain flow, inclusion count, and microstructural integrity. Samples are polished, etched, and magnified to understand what is really going on at the microscopic level. This test is performed to evaluate the grain flow validation. Good forging is equal to directional grain flow aligned to the part geometry. Heat treatment audit ensures uniform transformation and tempering, avoiding martensitic brittleness or improper phase balance. Failure analysis helps trace fracture origin, inclusion issues, or non-metallic contamination. You cannot see structure with the naked eye, but it will define how your part performs under stress. Number 6. MPI or NDT, magnetic particle inspection or die penetrate. Surface cracks are the silent killers of forged parts. Magnetic particle inspection and die penetrate testing reveals subsurface or surface defects invisible to visual inspection. This test is performed to evaluate the crack detection in machined forgings, especially in load bearing and fatigue sensitive parts like gear blanks, crankshafts, etc. Post heat treatment QC detect quench cracks or grinding burns. Critical parts certification required in industries like railways, oil and gas, or aerospace, where failure is equal to disaster. If your current supplier does not have these machines or avoids showing them, you are not buying parts. You are buying risk. We do not just forge parts, we prove they are ready. Thank you. See you in my next video.